After World War II, the US needed a global military presence to counter the Soviet threat, support allies, and stabilize volatile regions. This demanded a fleet that could stay at sea for months without refueling. Traditional carriers relied on vulnerable fuel tankers. Meanwhile, the US had already built its first nuclear submarine, the USS Nautilus, proving that nuclear power offered unmatched endurance, speed, and range. The next logical step, a nuclear-powered aircraft carrier. The driving force behind the idea? Admiral Hyman Rickover, the relentless, detail-obsessed father of the U.S. nuclear Navy. He personally selected engineers, enforced strict safety standards, and oversaw both the Nautilus and, eventually, the world's first nuclear aircraft carrier. And here it is, USS Enterprise CVN-65, the world's first nuclear aircraft carrier. A true giant, a revolutionary vessel that redefined naval warfare. It was designed not just as an aircraft carrier, but as a symbol of U.S. superiority in the nuclear age. When it set sail in 1961, the world witnessed the longest ship in naval history, the first ever nuclear-powered carrier, a colossal air wing capable of carrying nearly 90 aircraft. Unlike later carriers, which had 2 nuclear reactors, the Enterprise had 8 A2W reactors, 2 for each of its 4 turbines. Why so many? It was an experiment. Engineers weren't sure how powerful a reactor needed to be, so they played it safe. The nuclear reserve allowed the ship to operate for decades without refueling. The reactors powered steam turbines, which in turn drove the ship's propellers and generated electricity. USS Enterprise measured 342 meters in length, nearly 3 football fields end to end. Its height, from keel to superstructure, was equivalent to a 23-story building. It displaced nearly 93,000 tons, even more when fully loaded. Its hull, made of high-strength steel, was reinforced to withstand the stress of aircraft launches and landings. The bow was slightly raised, featuring an angled flight deck, a design that became standard after World War II. The crew? Around 4,600 people. This behemoth became a legend, earning the nickname Big E after its World War II predecessor. Big E sent shockwaves around the world. The USSR accelerated its own aircraft carrier programs. The Enterprise remained a one-of-a-kind ship in its class. Over the decades, it saw action in the Vietnam War, operations in the Persian Gulf, and the war in Afghanistan. It served until 2012 and was officially decommissioned in 2017. The US quickly realized that nuclear power was the perfect solution for aircraft carriers and never looked back. And now, we move on to the true monster that became the backbone of the US Navy for half a century. The Nimitz class, the most numerous family of nuclear-powered aircraft carriers in human history. No other country has anything like it. By the late 1960s, the US Navy realized that while USS Enterprise was a grand project, but it was too complex to operate, 8 reactors were no joke, and too expensive to build and maintain. General Dynamics, Newport News Shipbuilding, the same shipyard that built the Enterprise, took on the new project. Thousands of engineers worked on it, including those with prior experience on the Big E. Their goals were clear: simplify the design. Compared to the Enterprise, use only 2 powerful reactors instead of 8, improve survivability and armor protection, standardize the project to allow for mass production, and make it so reliable that it would serve for 50 years with just one major refueling overhaul, midlife refueling. The first carrier of the Nimitz class was named USS Nimitz, CVN-68, after Chester W. Nimitz, Fleet Admiral of the U.S. Navy and commander of U.S. Pacific Forces during World War II. Commissioned on May 3, 1975, it is still in service today. So, what was the result? How did the Nimitz differ from its predecessor? Instead of 8 reactors, it had 2 A4W nuclear reactors developed by Westinghouse. Powerful, reliable, designed for 23 to 25 years of operation before refueling. They produce up to 260,000 horsepower, enabling speeds over 30 knots, over 55 kilometers an hour. This made operations cheaper and the internal layout more compact. The ship measures 333 meters in length, slightly less than the Enterprise. It has reinforced armor and an advanced multi-layered defense system against torpedoes and missiles. A large angled flight deck, 4 catapults, and 4 arresting gear systems. It carries up to 90 aircraft and helicopters. The crew of a Nimitz-class carrier ranges from 5,000 to 5,600 personnel. Yes, it's like a small city with its own hospital, kitchens, engineering workshops, and even a jail. From 1975, the commissioning of USS Nimitz, to 2009, the commissioning of USS George H.W. Bush, the U.S. Navy acquired an entire squadron of nuclear-powered aircraft carriers, forming the backbone of the American ocean control strategy. The Nimitz class became the golden mean between the ambitious but expensive Enterprise and the new Ford class. Powerful but affordable, standardized yet flexible, massive but manageable. These carriers are the Navy's workhorses, and all 10 are still in active service. The Nimitz's first deployment was to the Middle East at the start of the oil conflicts, when America needed to protect maritime routes. Now, let's take a closer look at each member of the family. The next in line after CVN-68 was logically CVN-69. Its name is USS Dwight D. Eisenhower. The year of 1977. At that time, the US and the USSR were keeping the world on a knife's edge. The Eisenhower sailed out as a floating bastion of freedom, participating in operations in the Red Sea, the Mediterranean, and the Persian Gulf. Advanced radars and satellite communications began to be tested on board. The ship became smarter than its older brother. Next Nimitz, USS Carl Vinson, CVN-70, year of 1982. This was during the Reagan administration's 600-ship Navy plan, the largest naval expansion in history. The Carl Vinson became a symbol of the return of an aggressive U.S. fleet, dominating the Pacific and Indian Oceans. It was among the first to integrate computerized combat information systems and advanced aviation command technology. This was already a smart ship, capable of coordinating dozens of aircraft in real time. USS Theodore Roosevelt, CVN-71, year of 1986. This carrier saw the end of the Cold War and participated in Operation Desert Storm. It was the first in the series to introduce a significant female crew. It was a step into the future. For the first time, women served on a combat aircraft carrier as officers and specialists. Technically, it featured new catapults and an automated flight control system. No more shouting into megaphones. Everything was managed via sensors, screens, and calculations. USS Abraham Lincoln, CVN-72, year of 1989. The last aircraft carrier of the Cold War. It entered service 2 years before the Soviet Union collapsed. Lincoln witnessed a new world where the enemy was no longer a single empire, but chaos across multiple regions: Somalia, Bosnia, Rwanda, Iraq. In this new world, Lincoln became a mobile crisis response airbase. It introduced satellite video links, direct connections to the White House, and GPS-guided precision strikes. USS George Washington, CVN-73, year of 1992. By the time GW was commissioned, the USSR was gone, and China was just beginning to rise. It became the first major U.S. force projection in the Pacific. For the first time, training sessions were held on board together with the Japanese and South Korean air forces, and the aircraft carrier became a symbol of the new balance of power in Asia. Subsequently, it became the first American nuclear-powered aircraft carrier assigned to Japan, U.S. Naval Base Yokosuka. USS John C. Stennis, CVN-74, year of 1995. Stennis entered the fleet during the rapid expansion of the internet and digital technologies. It was the first carrier to receive a fully integrated, network-centric combat information system, the core of the new network-centric warfare concept. It also pioneered an updated close-range missile defense system, including early versions of the RIM-116 RAM. USS Harry S. Truman, CVN-75, year of 1998. Aircraft carrier of the era of pinpoint strikes. Truman saw action in Kosovo and Afghanistan, launching aircraft equipped with laser-guided and GPS-guided munitions. It became the platform for surgical airstrikes, not area bombing, but precise hits on specific targets. USS Ronald Reagan, CVN-66, year of 2003. The first carrier of the new millennium. Commissioned at the height of the War on Terror, it became the second floating U.S. embassy in Asia, after George Washington. It received improved underwater attack defenses, new radar systems, electronic warfare suites, and played a key role in countering China. USS George H.W. Bush, CVN-77, year of 2009. The last and most advanced of the Nimitz class, Bush served as a bridge between the Nimitz and Ford classes, incorporating future technologies. The new AN Spy-3 radar, more automated aircraft servicing processes, improved catapults, and the lowest crew requirement of the entire series, down to 5,000 personnel. What made the Nimitz class legendary? Each generation adapted to political and technological realities, from the Cold War to the War on Terror. Every ship has been modernized throughout its service. None have remained vintage. These carriers are the pillars of U.S. global influence. Without them, modern military doctrine would be impossible, and they are all still in service. First, the USS Nimitz is still in service, and it's almost as old as Star Wars. Now, it's time to step into the era of futurism, when warships begin to think. We're flying aboard the USS Gerald R. Ford, CVN-78, the most expensive and technologically advanced warship in human history. Why did America decide to build a new aircraft carrier? By the early 2000s, the Nimitz class had become outdated. Let's take a critical look at its shortcomings. Reactors need to be recharged in the middle of their service life. Flight deck operations had hit a physical limit, launch speed, maintenance. The old steam catapults were heavy and temperamental, and the crew size was still enormous, yet reducing it seemed impossible, as many processes relied on manual labor. The world has changed. The war on terrorism, Iraq, Afghanistan. It became obvious that future conflicts will be mobile, high-tech, and require an instant response. That meant more aircraft in the air per unit of time, fewer personnel, and greater energy output. The Pentagon realized it needed an aircraft carrier that could deliver more, faster, and at lower cost, without relying on more people. The project kicked off in the late 1990s, with development once again entrusted to the legendary Newport News shipbuilding. It was here, in Virginia, that the USS Gerald R. Ford, CVN-78, was launched on October 11, 2013. It was officially put into service on July 22, 2017. It was one of the longest construction and testing processes in U.S. naval history, precisely because of the complexity of the new technologies being implemented for the first time. The total cost of the project is more than $13 billion. This is the most expensive warship in history. Why was the newcomer named Gerald R. Ford? In honor of the 38th President of the United States, who served on an aircraft carrier during World War II. He wasn't a military genius, but his name became a symbol of continuity and steady strength, perfect for a new class of warships. Now, let's take a look under the hood. Length, 337 meters, about 3.5 football fields. Width, flight deck, 78 meters. Draft, 12.5 meters. Displacement, over 100,000 tons. 2 A-1B nuclear reactors, developed by Bechtel. Power output, over 700 milliwatts, 3 times that of the Nimitz-class reactors. Reactor lifespan, up to 25 years without refueling. This means enough energy for electromagnetic catapults, lasers, drones, satellite systems, and anything else the Pentagon might need. Speed, 30+ knots, around 56 or more kilometers an hour. Range, unlimited, practically constrained only by food and ammunition supplies. Number of aircraft, up to 75 to 90 units, including FA-18 Super Hornet, F-35C Lightning II, 5th generation fighters, E-2D Advanced Hawkeye, airborne early warning aircraft, EA-18G Growler, electronic warfare, MH-60RS Seahawk, helicopters. MQ-25 Stingray, unmanned aerial refueling system. Catapults. 4 EMALS, electromagnetic aircraft launch system. Electromagnetic catapults instead of steam ones. Lighter, more efficient, and with reduced wear. Aircraft finishers. 3 AAG, advanced arrest gear. A new system for capturing aircraft during landing. Number of takeoffs and landings per day, up to 160, with a peak potential of 220. Finally, the crew size has been reduced. Ford requires only 2,600 sailors. So who does the rest of the work? The Integrated Combat System. Its digital infrastructure manages everything, from weapons to toilets. Real-time monitoring and control. Full readiness for AI integration and autonomous systems. Even the ammunition transport system is fully automated, magnetic lifts. Instead of 5 or 6 sailors manually rolling bombs and missiles, an intelligent system now handles everything with magnetic and hydraulic lifts. Ford has no analog systems. None. Every aspect, from radar to restrooms, is connected to an integrated digital network. The ship sees, hears, thinks, and transmits everything to command in real time. Ford has a reserve for the future. For laser weapons, electromagnetic guns, railguns, combat drones, satellite communications and quantum communications, and hypersonic systems. All that remains is to implement them. In 2022 to 2023, Ford completed its first full operational deployment. It has already conducted missions in Europe and the Mediterranean, refining interoperability with F-35s and drones. Its design is already shaping the next generation of carriers. USS John F. Kennedy, CVN-69, nearly complete. USS Enterprise, CVN-80, under construction. USS Doris Miller, CVN-81, in the planning phase. Gerald R. Ford is more than just an aircraft carrier. It is a platform for a war that hasn't been invented yet. It is designed to keep America one step ahead in the era of hypersonic, artificial intelligence, quantum computers, and orbiting drones. And yet, it remains what the Nimitz and Enterprise were before it, a floating nation. A symbol, an argument, and a conversation without words. And how did America's main rivals in the arms race, China and Russia, respond to its arrival? Ford's debut caused serious concern in Beijing. China's answer is the Fujian Type 003, the first Chinese aircraft carrier with electromagnetic catapults, a clone of EMALS. Launched in 2022, it has not yet been put into combat service. And Russia? Russia has not built aircraft carriers since the 1990s. Its only carrier, Admiral Kuznetsov, is more of a tragic comedy than a flagship. It has been under repair since 2017. So today, the United States is armed with 11 aircraft carriers, a floating military empire. And yet, 11 is not too many. In fact, it's the bare minimum for America. After all, the United States is pursuing a policy of projecting power around the world. And to do this, they need to have an aircraft carrier in the Persian Gulf, off the coast of China, in the Mediterranean Sea, off the coast of Korea or Japan. One in reserve in case of a crisis, several more for the repair, preparation, reloading of nuclear reactors. Out of 11, only 6 to 7 are actively deployed at any given time. The rest are all in the service cycle. And only in the US are all aircraft carriers nuclear-powered. No other nation can launch 80 aircraft from a ship 160 kilometers off the coast and start a war in 30 minutes. America's 11 nuclear carriers are the most expensive, complex, and powerful weapons ever built. This is an ocean chessboard with 11 kings in the United States. The rest have pawns and knights.